All right. Thank you, Daniel, and welcome everyone to the Bluey webinar series. Today we'll be covering mixing and pumping of cementitious grout. So the mixing and pumping basics, what we need to look for: one, product selection, the mixing equipment selection, pumping equipment, your site setup, the temperature, and PPE. So we'll cover across all these topics throughout the presentation and go through everything in a little bit more detail. So the first part is product selection. So it's critical to understand the project performance specifications before you select your product. So that's in your strength, your setting times, how fast do you need a fast set, a slow set product, what's the design life of the product for the project, and all those sort of aspects. Also need to understand the application requirements, as this can influence your product selection. So do you need to pump the product a long distance? Is it a very large pore element? So that'll make a difference to the product selection and everything like that. So you got to look at all the aspects from the product specification to the project requirements before you choose your product. And all products have very different mixing and pumping characteristics. So they'll influence what type of pump and mixer you use for the product. So now we look at the mixing of the product once you've chosen your product. There's a lot of things to consider before you start mixing. Water has an influence, your temperature, both in the atmospheric temperature and the subset temperature. The yield and volume, your curing requirements, both setting times as well as your curing of the product, any additives to add into the products, and then your mixer selection. So water is probably one of the most critical aspects for mixing grout. There's a lot of different water addition rates for every single product on the marketplace. And the water addition rates will have a big influence on your durability of the product, the viscosity of your product, the stability, and the strength gain. So you can see the image on your right-hand side there is showing the success rate. So every product on the data sheet will have a lower limit and an upper limit for the addition of to your grout. And this will make a big difference for your product itself. So you can see there in the red zone is either too wet or too dry. So it's not going to be pumpable, or it's not going to do the performance requirements of that grout you've chosen. And you must use potable water when mixing grouts. Don't use water from a river, don't use dirty water, anything like that. So with the water, like we talked about, high volumes of water can produce weaker grouts. They can produce a less viscous grout, and they can also cause segregation. So what we're talking about there, if you go outside those limits of your water addition to your grout, what will happen is that your grouts, your cement particles, your sand that is in the grout to help it being a non-shrink grout can lose suspension, drop out. This can cause issues with getting pumps blocked, mixers blocked, and not having a great performance in your grout. So, and then on the other end, lower water volumes can affect pumping as well, because they're not being as viscous a grout. They can also hurt your hydration of the grout. So if you don't have enough water in your product, then this can cause the strength gain to stall at a certain period of time. So you need a certain amount of water to hydrate all your cement particles. The temperature plays a key role when mixing and pumping cementitious materials. Every 10 degrees increase or decrease in your temperature, that will either double or half the working time of your cementitious material. So what we're talking about there is on the TDS of a product that you've chosen, they'll have a working time, a set time for the grout. And these are generally tested at 20 degrees in the lab conditions. So if you've got a typical grout you're working with and it said you had 30 minutes working time, that's based at 20 degrees. So what we're saying is, if that becomes 30 degrees in temperature for your application, what happens is that 30 minutes working time will become 15 minutes. And if you go the other way, if you're down at 10 degrees, that 30 minutes will become 60 minutes. So you need to consider this when you're doing your application, because if you're looking at a fast set grout and you need it to be back in the service quickly, when it's in colder temperatures, you need to allow for that extra working time. So water temperature should be kept as low as possible when you're doing your mixing, so you don't cause heat of hydration happening quicker in your grout. It can also, you can use in very high temperatures, you can use chilled water, or you can also air condition containers for your powder storage. You can see the image on your right hand side, keeping the powder underneath a tarpaulin to reduce the heat of the powder, because the powder will have a greater effect on reducing the temperature of the grout. You're looking at the volume you're putting in there, a 20 kilo bag of grout can be having 2 to 4, maybe 5 litres of water added into it. So there's a lot more heat in that cement than there is in the water. So yield and volume is what I think to consider when you're looking at your mixing of your grout and pumping. There's no point in mixing more material than you can pump before it sets. This will just cause issues of blocking your pumps, the material going off in the mixer. So ensuring you have enough product on site, including wastage, so you have a continuous pour and you're not stop starting. And ensure that the size of the element you're pouring is suitable for the grout. If you have a pour that's outside of the limits of the grout, you'll cause cracking in your element and everything like that, which is not good for structural performance. So curing times, like we talked about, the temperature will have a big effect on this, so you need to understand what you're working with in those aspects. And the curing of a grout goes through 4 or 5 different phases. So first you have your product will start to increase in viscosity, so it'll start to get a little bit thicker and lose its workability. And then you'll have the gel phase, and then you go into initial set and final set for the product in your curing phase. So it's critical to know these aspects. So you're not moving a grout or working a grout when you're hitting the gel phase. It can cause issues in performance, segregation of the grout and particles. If you start working or try to finish a grout once it's... One thing you can manipulate is if you keep the grout moving in the mixer, it'll onset the gel phase and prolong the curing time. This is important to know for fast setting grouts. Curing compounds are recommended for most standard cementitious materials. For fast set grouts don't typically require curing compounds because most of the reactions happen in a very short period of time and you have a full cure within an hour to 2 hours. But are used when you have very challenging temperature conditions with high winds and high temperatures. So the curing methods, why we cure the grouts, it provides a high quality surface, it maintains the moisture within the product to give you correct curing of the grout and getting all its properties. It minimises your plastic cracking, and there's different ways of doing a curing. You've got curing agents, water-based, wax emulsion or acrylic. You can also use a wet cure by putting wet Hessian bags over top of the grout or your concrete pours. And they are applied as soon as you finish processing and hitting your initial set. So when we're looking at additives for grouts, most proprietary grouts on the marketplace have all the additives added into the product already, these super plasticizers and retarders. So the super plasticizers, these are water reducing agents, so allowing us to add less water into your mix to get a more durable, more flowable product without the addition of extra water. So there's no need to add extra additives to the products on site. Retarders are in there for your set control and mainly for your fast set grouts. These are more critical for. And then your stabilizers, these help with your segregation and keeping your cement particles and aggregates in suspension so you don't get segregation and pumping issues. Now there's mixer selection. There are different types of mixers for different applications for your different grouts. These are the sort of the main products, main mixers on the market. You've got a pan and paddle mixers, colloidal and high shear batch mixers. Continuous mixers, you've got volumetric, which is a bigger version of a continuous mixer. Then your concrete agitators. So I'll just give you a run through all the different types of mixers and what they're good for and the application of these mixers. So a pan and paddle mixer involves stirring action that generates a minus shearing forces. So these are suitable for products that have a design for high proportion solids and require low shear forces. So a high performance grout, a very fluid grout, are not suitable for using pan and paddle mixers because they don't give you enough shear and they're a very slow mixing application. So you can see the photo on the right hand side is a typical pan mixer. They're generally suitable for micro concretes or concrete mixers, fixture topic grouts, because you've got blades that go all the way to the outside and mix and move these grouts and mix them properly. You can see the image on the right hand side there. You can actually include baffles on the side of the pans to give you more shear forces in these pan and paddle mixers. Good for non-shrink grouts and screeds. So more viscous products, the thicker they are with aggregates, is perfect for these type of mixers. Then you move to your colloidal and your high shear batch mixers. The mixing process for the colloidal mixers is creating high shear forces and moving different ingredients at different speeds. These are very efficient mixers and designed for your high performance PT grouts and high flowable grouts. They mix very quickly and very efficiently. You can see the type of colloidal mixer on the right hand side you've got your mixing element here, which is mixing it, and then you've got a holding tank on the other side. So once it's all been mixed and placed, it'll then transfer it into a holding tank, which can then be pumped from those applications. So then you've got a high shear batch mixer. These are a smaller version of a colloidal mixer. So similar sort of application. You've got a mixing vane in the middle, which creates a vortex when you're doing your mixing, and very good shear capacity. So again, good for your post-tensioning grouts and high fluid grouts, and good for mixing high volumes. So these are just what the type of grouts we've been talking about for these types of mixers. There's another mixer on the right-hand side there, which is a typical post-tension grout mixer. So it's known as a Dipman pump. You've got a vane in the middle, creating a good shear capacity, and that's a mixer and pump in one. Continuous mixers. These use a constant feed of dry product into the hopper, and then you have an inline static mixer where water is added automatically into the mix. So you have your powder addition up here, drops into the hopper, has a worm drive, and this is where your water addition gets added into your mixer. It's a simple operation used commonly within tunneling and mining. It's not suitable for high performance grounds like your PT. With your PT, you're a lot of plasticizers in there, which take 2 to 3 minutes to dissolve in your mixing. In these sort of mixes, you've only got a very short mixing window, so you don't get a lot of shear capacity in there to dissolve all those plasticizers, so it can be adverse effects to your grouts. Volumetric mixers are a bigger version used for high volume grouts, micro concretes and large concrete pours, used for fast setting grouts as well. So same sort of operation, you've got different powder and aggregate bins all getting added into them and mixing in the auger. So mixed on site to suit the application. So you have no travel times, you're not having product going off in a mixer, and you can get it enough as required. So concrete agitators. Most people think that concrete agitators are only used for concrete mixers. These are one of the most effective ways of mixing all types of grouts, from high fluid grouts, post-tension grouts, micro concretes, non-shrink grouts. Over the years, Blueys have done a lot of work mixing and delivering grouts in the back of Additives. We find it one of the best ways to do it. If you've got the access, you've got a large pour to do, then this is the way we try to do it, using bulk bags or even from a batch plant as well. So they give you very high shear. You've got the quality control because everything is going into the mixer. If it's getting done at a batch plant, you've got them way batched. So the water addition, everything else is done very well. So don't be scared of using a concrete agitator for doing your mixing. If you've got the access on site and the ability and large pours, this is one thing to consider. So just a little overview for the mixers. There are various types of models of each type of mixer. So there's plenty of different pan mixers, colloidals. So it's about choosing the one that's suitable for the product and your application. So match your application specifications with your mixer and match the size and the power requirements as well for these sites. So some of these mixers are free-phase power, so you need a lot of power to run some of these bigger mixers. If you don't have free-phase access to that on site, so just make sure you're choosing the right mixer to what you have on site. Now the best ways for mixing the products. You've got to look at pre-planning your work area. So try to mix as close as possible to the where you're going to be doing your work. You don't want to be pumping a long distance. Having ease of access to water supply. This is generally one of the slowest part of doing grout mixing, is getting your water into your mixer or into your agitator bowl. So having a good access to the water is critical. And again, like we talked about before, having good power supply to match your mixers, and allowing for the disposal of your waste material and washout. Making sure you've got an easy access area you can put all your bags into a bin close by, so you're not having them lying around on the bags. And then also looking at planning your lifting equipment. If you're using bulk bags, you need a working platform to work from, cranes or men or tubes to be able to lift these up safely. So mixing basic again. If you've got a high production rates, a big volume pour during the day, you might need multiple mixers and pumping stations set up. So you've got to look at the application on site and that you plan this. So you might not just be one mixer, you might need 2 or 3 stations set up. So having them planned out, having your product there so you can easily access it all. Checking the mixer is clean and working correctly before you start. And then checking that you have the correct product. I've seen it plenty of times. Sometimes there are 2-part products where you're doing a part A, part B. making sure that both you have the correct part A and part B. Nothing worse than putting in the wrong product and having an issue going on site. We've all seen it gone wrong before. And one of the critical things is adding the water, calibrating the water addition. So a lot of flow meters, you've got measuring vessels that you can get, buckets that have measurements on the side from Bunnings, just checking that these measurements are correct before you start. So if you're using a measuring bucket that has things there, weigh the water to check that they're actual accurate. Some of these buckets we've checked before can be out by 10 to 20%. And then the flow meters as well. These can go out of calibration very quickly. So this should be calibrated every day or twice a day, making sure that they are still inaccurate. We always get calls from people on site saying that your grout hasn't achieved strength. We go out there and double check. First thing we want to do is check the calibration, how they're adding the water to make sure that they say they're putting in 4 litres. You check the calibration, it could be putting 5 or 6 litres in there. So that'll have a huge effect on the strength gain of the product and the performance. So the best way of mixing a grout is adding in 80 to 90% of the water first into the mixer. Don't add the full, if it's 4 litres a bag, don't add in the full 4 litres. Add in 3.5 litres a bag first so that you can add the balance in at the end. And then you're adding the powder in slowly to the bowl. Not too slow, not too fast. If you add it in too slow, it takes too long to mix, then you're adding more heat into the process. If you're going in too fast, you can cause it not to mix properly, causing a build-up on the side of the mixer and everything like that. So once you've added in all the powder, make sure you give it a good mix for a minimum of 3 minutes, or depending on what the TDS says for the product you've chosen. And then you can add the balance of the water at the end to give you desired flow characteristics. So if you add all the water at the start, then you're stuck. You can't take water out. If you add in more water, then you've gone over your limits, which will cause issues. So it's always best to mix it a little bit thicker at the start. That'll give you more shear in your mixing process. So quality control on site. So testing of your grouts once you've done all your mixing. So these are the standard sort of testing that gets done. You got your compressor strength for your cube molds. You have a mud balance that you can do for checking your density. A flow cone for your fluid grouts. So that's the image on the right-hand side, just doing a flow cone check. And then you have a cup test, which is a simple little test for thixotropic grouts where you put the grout in a cup, turn it upside down, make sure it stays in there. This is a test we do for rock bulk grouts on site to make sure they've mixed it and added the right water. Now we're moving on to the different types of pumps and pumping procedures. There's a whole heap of different pumps that you can use for mixing, for pumping grouts, and they all have different requirements. Different grouts are not suitable for all the different types of pumps. So the main pumps that get used are piston pumps. The photo on the right-hand side there is showing some Clark Mining piston pumps used for good fluid grouts, non-shrink grouts. Not good for grouts with aggregates. Then you have a mono worm pump, a squeeze pump, diaphragm pumps, and then your traditional concrete pumps. So these are just some images there. The image on your left is a diaphragm pump. These are very versatile pumps and good for a wide range of different applications. Good for fast setting grouts. They're very simple, not much can go wrong with them, and good for high volumes as well. So the one in the middle there is a mixer and pump, a piston pump. So these are good for your fluid grouts. They can be used for fast set grouts as well. Not good for grouts with aggregates. You can use a non-shrink grout with a small sand content, but anything with a higher sand content, that's not good for. The photo on the right there is a worm drive pump. So you'll have the 2 mixers on top, which are pan mixers, and then you have your worm drive in the middle. So these are good for most grouts, even up to aggregates up to 3 to 5 mil, depending on the supply of the worm drive pump. The Breedle pump there on the left-hand side is a squeeze pump. These are good for pumping long distances, good for post-tensioning works, for low pressure, high volumes and low pressures, and also pumping for long distances as well. So, and then you have a traditional concrete pump in the middle. These can be used for a wide range of grouts, for fluid grouts up to grouts with large aggregates. And then again, on the right-hand side is just another version of a worm drive mixer and pump. So with the pump, choosing the correct pump for your product must be chosen. So no point using a piston pump if you've got an aggregate with a grout with an aggregate in there. So choosing this is critical. Keeping the pumping distance to a minimum. If you don't have to pump at 100 metres to get to the location, keep it down to as low as possible. This will reduce your pressures, your risk of blockages, and also any loss of pressure over that distance. Have your hoses running straight, no bend, try to eliminate as many bends as possible. Also eliminate reduction in hose sizes. So the more reductions, if you're going from a 4-inch down to a 3 and 2 inches in hoses, every reduction is more pressure and more risk of blockages. So if you have to have any reductions, make sure that they're a conical reduction in your hoses. With your hoses, make sure you've got the right pressure rating on your hoses to be greater than the maximum anticipated pressure you have for pumping. Have spare hoses and connections. You have any issues, you can quickly change out a hose and put in a new hose for your pump. Inspect and test your pump prior to starting. Make sure everything is working, all your connections are done properly and in place. And then prime and flush the pumps with water and a grout slurry. This will reduce your pressures in your pumping lines. And a critical part is safety. Ensure the correct PPE is worn. You've got gloves on, eye protection, dust masks, everything like that. The alkalinity of grouts can cause skin burn. So if you're doing mixing and pumping all day, make sure the guys have all the correct PPE in place. Allow for appropriate washout areas, and don't run the pump dry with no material. This has a lot of different issues. You can cause air pockets within your line, which will then create pressures and blockages and even blow lines. And it's also not good for your pump running them dry. Make sure all your safety connections on the pump are in place. So hose clamps and clips, so you don't have any blowouts. If you're using very high pressures, having change on there so you don't, that all an extra safety issues. And make sure all your pumps and mixers have safety covers and cut-off switches. So if there's no way of putting hands into moving parts and causing any safety injuries on site. Nothing you want to have is any of you guys coming home and losing and causing damages to themselves. So that's the end of the mixing and pumping. I hope that it was a little bit of an overview of different types of mixers and pumps. If you have any questions, you can either email myself directly, or if you have any questions now, you can unmute yourself or type it into the chat box. Thank you.
Thank you, Greg. Appreciate that. That was a good summary and overview of pumping and mixing. Often we get a lot of questions in that area, so it's good to have something where we just cover those topics, and it does vary a lot depending on the grout and the type of application. So we've got a question here from Ryan Young to you, Greg. Is there a stipulated size of grout cubes for compressive strength testing?
It depends on the grout you're using. If you have a grout that has no aggregate in there, the standards call for a 50 mil is the most common, 50 to 70 mil, and then there's 75s. If you've got aggregate in your grout, depending on the size of aggregate, if you've got a less than a 5 mil, you can still do 75 mil cubes, but any larger, then you go to 100 mil cubes. But don't use cylinders for testing in grouts. The reason
we don't use cylinders is because it introduces shear into the test, and you're not actually measuring compressive strength, then you're measuring shear and tensile forces where it's not symmetrical for length and width. So that's why we don't use cylinders for grouts without aggregates or large aggregates like concrete. So cylinders are really only for concrete. And just to clarify as well, Greg was talking about using steel molds and steel cubes. What we're saying there is steer away. There's a lot of polystyrene cubes on the market that you can buy. They're really cheap, easy to fill, obviously, and you know, disposable. But rarely are the sides perfectly parallel. So that's why you get that reduction in strength, because the quality of the cube you produce is lower, and also it sucks a little bit of moisture out of the surface of the grout. So you're not getting representative strengths of those cubes as well. Also, the other issue with the polystyrene cubes is that you can't tap your cubes. You can't get your air out of them. You can't put a steel rod in there to rod your grout to make sure you get all your air voids out of it. So yes, the polystyrenes are cheaper, but we're relying on that data for opening up roads or putting load onto these areas. So use steel cubes wherever possible. Got another question there from Eddie Tan. Can we still add mixtures to a grout using the pumps where the cement and water is added at the final stage of the pump? If you're talking about the systems where you're moving dry powders and then adding water at the nozzle, then the additives would have to be added in a powder format, which is definitely possible. We do that all the time. So rather than using a liquid additive, so a liquid superplasticizer, you'd be using a powder superplasticizer, which would be mixed in with your powder. So the answer is yes, it's still possible to add additives. They would just be in a different format.
You want to just check as well, Daniel, just to make sure that with your grout supplier that whatever you are adding is suitable and compatible with the grout. It doesn't have any adverse effects. So
yeah, typically if it's a powder admixture, it would be added by your supplier and supplied as a pre-packaged mix. Anyway, I would assume. But yeah, you should always check if you're adding anything extra. So thank you again for joining us. We may see you again in a couple of hours. If not, hopefully you can join us again tomorrow. Thank you again for your time. Appreciate it.